Hello everyone and welcome to the third episode of Coding in RStudio. Today I wanted to go over packages, grammar, and functions. So packages are tools that exist to make projects easier to write, make them more applicable, make them more readable, so on and so forth. Um, Today I'll go over the tidyverse package. It's what I use in majority of my work day to day. It helps keep things neat and tidy, and the grammar of this package I think is pretty easy to read as well. Um, so when I'm talking about grammar, grammar in a coding language just means how code is written to be accepted by a compiler. So coding languages like Java or other coding languages use semicolons and stuff like that when you're trying to go between different lines. But languages like R and Python don't always have to use semicolons. Um, so today, like I was mentioning, I'll go over the tidyverse package. When you're installing a package, go down to your console here. You're going to type in install packages, and we're going to put in the package name in quotations. So we'll put tidyverse, and it should go ahead and start installing your package for you. And then once that's completed, we'll go ahead and go up to here, up until the up into your coding itself, and we're going to load in this package once this is done installing. And it looks like we should be good to go. All right, and we have this confirmation here down at the bottom. So packages usually include functions that you can't see just by looking at the UI itself. But when you're writing out your code, you can see that it starts to try to autofill some of those functions while you're writing it out. So when you're loading in a package, we're just going to call it library, which is where the package is stored within your C drive. We're calling library in the tidyverse, and we're going to do our control and enter to run that. And you can see that it's loaded out the tidyverse package down here. So like I was mentioning, packages are usually collections of functions and things that are in the background to help, clean your code up or make functions easier. So we'll go over the tidyverse package, just the basic grammar of the package itself. And then you can use this for other packages that you might find through different Googles and other research that might be more applicable to the projects that you're doing. So we are going to go ahead and make a data frame to work off of for this. So I'm going to type this out manually. Whenever I'm doing, an introduction to any sort of coding language, I usually go off of a fruit basket example, and I'll explain what I mean there. So we're going to make a data frame, and we're going to call it fruit basket. And we're going to call the data.frame function, and you can see here, like I was mentioning, this is just in the base R. This isn't in tidyverse, but this is one of the functions that are included there. So we're calling the data.frame function here, where we're making a data frame and then setting it equal to, or setting fruit basket equal to this data frame. So we'll make apples as one, and we'll just set it to 1, 2, 3. We're going to have 3 observations here. So apples will be one of them. We'll make bananas 1, 4, 5, 6. We'll do cherries 7, 8, 9, and then let's make a column that talks about like the basket color or something like that, like some kind of a unique identifier for the rows. So we'll say basket is equal to C brown, red, yellow. So just kind of describing what I'm writing here. This function apple, or this part of the data.frame line here, apples just means this is the column header, and then these are the values that correspond to it. So if we had to imagine, let's just say like apples, and then there's 1 apple in one basket, 2 apples in another basket, 3 apples in another basket. Bananas, same thing. Cherries, same thing. And we're making this column here to describe like the 3 different types of baskets that we're running with. So we're going to hit Control and Enter here. And you can see over here in our environment that fruit basket pops up over here. So we're going to click it and then look at it. So We've got 1 apple, 4 bananas, 7 cherries in the brown basket, 2, 5, 8 in the red, 3, 6, 9 in the yellow. So that's just, kind of one of the basic ways that you would be able to create your own data frame for testing stuff. But oftentimes you may be reading in a comma separate value sheet or an Excel spreadsheet, so you may not even necessarily have to do this for what your purposes are. So we're setting this data frame equal to fruit basket, and now I will go over the piping function that comes with tidyverse. So a pipe function is written out as a % less or greater than sign the %. What that means is just and then. So I'll explain what I mean here. So we're going to say, we have our variable fruit basket here. We're going to make a new basket equal to fruit basket. So if I just ran this by itself, all I'm doing is just making a copy of fruit basket and setting it to new basket. But now we're going to do a pipe function. So I'm setting new basket equal to fruit basket, and then I'm doing something else. And I'll go over, just one of the functions that comes with tidyverse here. This is one of the more simple ones. It's the mutate statement. So mutate, what mutate does is it takes, depending on the context of what you're running, it'll take whatever given, structure or function that you want to do with the values that are in here, and then set it equal to a new variable. So we're going to say mutate added apples, bananas. We're going to say mutate, and we're going to make a new column called added apples, bananas. Oh, I can spell bananas. Is equal to apples plus bananas. So we're taking, these rows and adding them together. Well, sorry, equals to apples plus bananas. You wouldn't put these in quotations because it's thinking that it's a character vector and they're numerics. 1, 2, 3, 4, 5, 6. Those are all numerics. So we took fruit basket, and then we're making new basket from fruit basket, and then we're adding apples and bananas together to give us a new column here. So yeah, so we have that column here, added apples, bananas, 5, 7, 9, which would be apple plus bananas. 1 plus 4 is 5, 2 plus 5 is 7, 3 plus 6 is 9. So that's the function of the mutate statement. It's basically taking, it's creating a new column, or if you wanted to, you can, manipulate a column that you already have. So like if I wanted to add apples, basically like I said, apples equals to apples plus 4 or something like that. It would take all of your apples numbers and add 4 to it. But we're taking this added apples, bananas column that we're creating in this statement and adding apples and bananas together. So just to recap, we're making fruit basket here as a data frame, and then we're setting new basket as the new variable from fruit basket, and then we're making added apples, bananas column. The reason why I do this here is because a lot of times when you're working through R code, you'll run into a scenario where you have like, if you were to set fruit basket equal to fruit basket, so what we're doing is we're taking our original data frame that we made, and then we're manipulating it to where this original data is now being rewritten or overwritten. The reason why you don't often want to do this unless you're sure that the code works correctly is because if you were to write like if you were to make a new column, no, actually, let's do this. If you were to take the first column that you had, apples, and then we're wanting to add 4 to it, you go back into the original data that you had before, and then you realize, oh shoot, I didn't want to add 4, I wanted to add 5. Well, the problem by doing that is you have overwritten the first read-in for your fruit basket variable. So what I mean by that is now you have to go back to get your old data. You have to rerun this again to get the data to reset back to 1, 2, 3. So that's why a lot of times you want to set a new variable to take a place of that. So if you got something screwed up in this mutate statement, you don't have to go back and read in your data again. This becomes a problem when you're working with tens of thousands of different observations, and you run into a problem where it's like, oh, my graph doesn't look right. What did I do wrong? Well, if you constantly rewrite your data over and over again, then you can't trace back, or it becomes a lot more difficult to trace back. So that's the the short and skinny of the grammar for tidyverse. There's many functions that are in tidyverse. This is just one of the very small ones. Um, as you saw when I was doing that install packages command down here, there were many different packages that were all included within the tidyverse package. Um, so lastly, I want to go over functions. Functions exist in many different coding languages. In R, the way functions work is not much different than what you're probably normally used to if you've written in functions before. So if we wanted to make a function, and the purpose of that is to make it so you don't have to constantly rewrite code over and over and over again, um, you let's make a function called add columns, and we're using this open bracket close bracket to define where the function starts and ends. In this little parentheses for this function, this is where parameters go. Parameters are expectations of what should be given to this function to do the code. So if I were going to add two columns together, I want to put like number 1 and number 2, because it's expecting that I'm going to be giving it two numbers to add together. So for this, we're just going to return num1 plus num2. So what I'm doing here is I'm giving this function two numbers, and then it's returning those numbers added together. The purpose of doing this is so you're not having to constantly, write this over and over again. You can just make it to where it's in a function, and you just have to call the function rather than having to write everything out. So we're going to take that same code and we're going to put it back behind here, and then we're going to run this code. That way that function is saved up here in our environment. So instead of doing apples plus bananas, let's do add columns, apples, bananas. So we're making this added apples bananas column, passing it the function add columns together, and we're giving it two numbers, which is like a number for each cell of apples and a number for each cell of bananas. We run it, and yeah, we should still get the same output 579 that we had before. So that's the basic concept of how functions work. You're giving a function parameters, and then it accepts it, and then does it whatever manipulation you need to, and then returns a number based on that. So if I wanted to do instead of returning num1 plus num2, if I wanted to do like result equals num1 plus num2 return result, it'll function the same way. So I'm making this result variable here, or we can use a pointer here if we want to as well. I'm making this variable result as a base of number 1 and number 2 that we're giving to the function, and then it returns the result. So run the add columns, and it should do the same thing. 579. So that's the general purpose of a function. It's just making it so you don't have to consistently rewrite the same code over and over again. This will help a lot with a lot of bigger data projects when you're having to run functions that may have to do with several hundred lines of different mathematical equations, or if you have to pass it a data frame and you have to manipulate the data frame, that sort of thing. It just makes it so you're not having to rewrite the same code over and over again to get the same results. And lastly, I'll just really quick touch on this idea too. A good practice for any coding, regardless of the languages you're doing, is writing through comments. Now, the comments, grammar for comments is different between different languages. The purpose of a comment is to write notes out for yourself. In R, it's with a pound sign or hashtag. We're writing these out for example, like for this function, I'm going to say that this function adds two numbers together and returns a result. The purpose of comments is to not only prevent yourself from getting lost when you're looking back through a lot of code, but it's also for anybody else that needs to look back through your code. Like if you're coding something that'll eventually become legacy software or something like that. It's so somebody can go back and look through, like, the thought processes of how you're writing out these functions, or what the purpose of these functions are. Um, Many different coding languages also offer a feature where, like, if you set like a certain amount of comment lines together, you can, I think in R it's 5. If you set, 2 of these together and then you click on this little drop down, it minimizes, the code that was between it. So you could do something like this, and then click that button, and then that, like, the function for this is within these 2 comment brackets. That can kind of help clean up code, or make it so, like, when you're having to read through a bunch of lines, that you're not having to do all that scrolling, or have to narrow your eyes to try to figure out where it is that you were working out of. But that's just the basic understanding of how the tidyverse package works and how grammar works, in R, as well as just the general idea of how functions work as well. But feel free to leave any questions down in the comments below. Otherwise, thank you for your time.